Hello everyone, in this tutorial we will create the tank that we can drive, aim and shoot, and we will use chaos vehicle to create this tank. First we go to Unreal Marketplace and search for M1 tank. And this is M1A1 Abrams tank, and it is free. You can download it and open in launcher. We open it in Epic Game Launcher. And after you download, you can search it inside the wall and add to any project that you want. And search for, I want to add to building project, this building tank. And because it is not compatible with version 5.2, we have to show all projects and select the closest alternative version is 4.27 and add to project. Now let's go to our project and we can see this tank inside, and we can open this level, and when we play, and this is the tank. We have the speed, the red rotation, gun elevation, and the line of the tank, the damage, fire. And we will create this system inside our tank that we can control it. And go to the map. I use the project that created before that use first person. This first person map. And if you want to create this destructible building, you can follow the last tutorial. But if you want to create the tank, you can use this tutorial. Now we have to go to plugin and search for chaos vehicle. And we enable this chaos vehicles plugin, and you need to restart it. And now go to this building destruction folder. I add new folder, name is tank. And right click, blueprint, search for vehicle, and select on this vehicle pound, and select, name it to BP tank. I create animation blueprint and select this skeleton mesh of the waste tank M1 and choose vehicle animation instance and create. Name it ABP tank. Now go to vehicle and this waste tank we need to create the physics asset for this tank. So click on the skeleton mesh, right click and create physics asset and create asset. Rename this to PHS tank and open this. So we need to delete all of this and open this physics asset and select on this thread, select on this body and Control Shift C, or you can right click and copy selected body to clipboard and paste this. Control Shift V, and the physics type is default. Next is this thread and this gun. Control Shift C and Control Shift V, and we have this physics asset. This thread we set it to kinematic, also with the gun, because we don't want it to simulate when we simulate the physics. If you simulate, the thread will fall down. And go to our tank skeleton mesh and use this new physics asset instead. It's already selected, so make sure it is the new physics asset. Close all of this. Now go to our BP tank blueprint and this mesh, choose the tank skeleton mesh and choose the animation blueprint tank. Inside this animation blueprint, type for mesh face ref pose and call wheel controller, and the alpha is 1. Because this animation blueprint is inherited from vehicle animation instance, so it have this wheel controller that can control the wheel of the vehicle. And back to our tank blueprint and add spring arm, add camera inside the spring arm, and the spring arm length we set it to 900, and the prop size is 12, and target offset is 125. Set the location to higher, so set it to 215, and we use pound control rotation. And let's add our tank to the scene. Drag this BP tank into the scene, and I feel it is too light, so set the tank to The scale is 0.95. Go to event graph, and we want to process the tank when we start playing. So get player controller and call process. And inbound is safe. And save. And for this verb setting, you have to set this default pound class to none because we don't want to spawn the first person character. When we play, now we can start with this tank. Then we want to add the controller for the camera. Call get controller has to player controller and get enhance input local subsystem is valid. Add mapping context. And this mapping context we choose IMC default. And we add another one. Is IMC weapon. And we can comment on this. Select and press C. Add mapping. Add the input mapping. Because this is the hand input, so we have to add this mapping. It's available in Unreal Engine 5.2. And we call the event IA look. This enhance action event. And split this action value X. Add controller your input trigger, and for Y add controller pitch input. Command on this is camera. And for the camera, we want to clamp the camera rotation. We don't want it to rotate around the vehicle 360 degree for the pitch. So create a sequence and get player camera manager. Then set view pitch min and set view pitch max. This view pitch min is -60 and view pitch max is 15. And compile, display, and when we rotate your mouse, you can rotate around this vehicle, and we cannot rotate under the vehicle. This is the great start. And inside this BP tank, we get the mesh and get anim instant has to ABP tank. And this ABP tank, we promote this to variable. Rename it to anim instant. And compile this. We need to create the wheel physics for this tank. So create blueprint class, search for wheel, and like this, chaos vehicle wheel. Name it to BP tank wheel. Open it, and this wheel radius is 32. The wheel width is 40, and the mass of the wheel 500 for each wheel. And slip threshold, set it to 1000. The skid threshold 1000, and set affected by handbrake, affected by engine, and this ABS enable. When you set it to affected by engine, this wheel will add the force to the vehicle when we move forward or backward. And go to suspension. You can adjust this for the physical of your tank. So let's set it to 5, and this make drop is 5. Spring rate is 5000. And set the smooth suspension smoothing to 1. And save. And go to BP tank. Open this vehicle movement component. And we will have some setting to set it. And this will set up. We need the skeletal mesh. And this is the wheel of our tank. The bone from wheel 8, wheel 7 to this wheel 2. And the right wheel is OT and the left wheel is LF. Go to this wheel setup and add the wheel, add 14 wheel. We start the index from 0, so it is 13. And for all these wheel, we set the wheel class to this BP tank wheel. We need to copy the name of the bone. Click on the bone and copy selected bone names. And paste it inside this bone name. The first wheel, the van wheel, Now we finish add this wheel. So we can go to the tank and add the curve. Search for curve and add this interpolated point, curve float, and select. Name it to FC cos curve. Open this. Add the key. This is X and Y. X is 1000 and Y is 150. Press F to focus that point and add new key. It is 2000 and Y 238. Go to the tank and scroll down and set this external curve is FC cos curve. And this curve we set it to this. And set the max torque to 4000. And this is the strength of the engine of our tank. And max RPM is 2500. This is the speed of the tank. Engine idle RPM is 2000. And the engine brake effect is 1. We want the tank to stop moving forward after we release the throttle. And engine rev down is 8000. If you don't like this adjustment, you always can adjust it later. And scroll down. The mass of the tank, set it to 10,000. The width 180. The drag coefficient set to 1. And enable the torque control. Your speed is 6. We set this large number because we want to rotate the tank with the yaw input, not from the steering, because the tank wheel cannot steer like the car wheel. Your input rate is rise rate is 100 and fall rate is 100. And let's save this. Now I want to change the enhanced input controller. So find this IMC default and open this. For IMU, we have W, S, A, and D. But this input action, I want to separate it. For W and S is one input action, and A and D is another input action. So go to action Add new input action. Name is IA turn. And open this. Set it to exist 1D float. And save. Open this IMC default WS. It's the same inside this IMO, but we don't want this A and D. Delete. And add mapping. Select the input action IA turn. And add key. First is A, next is D. For A, set the modifier to negate. It is negative. Save. And we can call IA move intent action event. And next is IA turn. Delete this action value. And for move forward and backward, we get this action value y greater or equal to 0. Then create a branch. Trigger complete next to this branch. Get vehicle movement component. Set throttle input. If it's true, we connect this action value y to this throttle input. And get vehicle movement component. Set brake input. And set the brake to 0. And if it's less than 0, we copy this. And the throttle, we can continue to set this value. But the brake, we can use this value y and multiply it with -1 and connect it to the brake. If we start or complete, we get vehicle movement component and set your input for start and cancel. Get vehicle movement component. Set throttle input to 0. Go to mesh. Scroll down. Simulate physics. If you don't set this simulate physics, the vehicle movement component will not work. So let's play test. And we have some problem. This problem happened because we use the track of the wheel. We should use the wheel instead. And so delete this track for all the wheel. Save and compile and play test. And let's press W. The tank will move forward. And when we press S, I forget to set this throttle when it is full. So let's play test. Now when we press W, the tank move forward. And when we press S, the tank move backward. Now I will show how to turn the tank. And go to this event tick, move it here. Get mesh. Get physics. Angular velocity in degrees. And get the vector length. And if it greater than 30, we want to, if it greater than 30, we want to stop the turn and set it to the variable stop turn. We don't want the tank to turn very fast. And go to enhance input action, IA turn. For the trigger, get stop turn, boolean, and create a branch. If it's true, we add new variable. Name is we call your, and set it to float. Get we call your and loop it to 0 with alpha is 0.1 and set it to we call your. Get vehicle movement component. Set your input, and this is your input we call your. And if it fall, we get this action value and set it to we call your. And get vehicle movement component. Set your input, and set this to the yaw. Because we have a little of bug when it's turned, when the vehicle don't have the velocity, the tank cannot turn. So we need to add a little bit of throttle before we turn. And at the start of this, we get vehicle movement component and set throttle input. Set the throttle to 0.1 when it starts. Get vehicle movement component and set your input to 0. Also, get vehicle movement component, set throttle input to 0. And set it when we cancel or complete. And compare save. Let's play test. Now when you press A, the tank can turn. When you press D, the tank can turn right. And we want to create the animation of the track. So go to the mesh, ABP tank, open this. You need to go to the tank, ABP base tank, and copy this update speed offset event, paste it to this event graph, mode this field speed offset to variable, and this update wheel, throw C, throw V, and promote this wheel speed and wheel rotation. Next is this update track material, throw C, and this, copy this, and promote this track MID, compile. Go to this BP instruction script and copy this dynamic material instance. Throw C and go to BP tank instruction script. You paste this dynamic material instance and promote this body material and this track material, and use this mesh as the skeleton mesh. In this BP waste tank event graph, we can find the speed of our vehicle. This set speed event. Copy this, but don't copy this wheel smoke intensity. Go to this event and paste it here. Set wheel speed and set it to the speed. Delete this and compile, save. When we update, we set speed and get vehicle movement component, get forward speed, and clamp the speed, clamp float, minus 500 and 500, and set it to the speed. File and save, and let's play. We not yet have the track animation. Go to ABP tank, and for the update animation, we need to update speed offset by using this data type X for increment, and call update track material, and call update wheel. Now let's compile and play test. And when we move forward, the track will have the animation, also with backward. When we stop, the track don't have the animation. And we want this wheel to rotate and this front wheel to rotate. So go to ABP tank and go to anim graph, copy bone, the bone rotation and source bone LF will 0.5 and the target bone is LF will 0.9. This LF will 0.9. And then copy this copy bone, and we want to copy the rotation from the wheel 5 this time we use the right wheel and wheel 9 and copy again. You can see the skeleton mesh. This wheel is OT wheel 9 and this front one is OT wheel 01. LF. So this is LF wheel 5 and the target is LF wheel 1. This one is OT wheel 1. And that's play test. Now this front and back have this wheel rotation. Now we want the track to follow the suspension of this wheel. So go to ABP tank and we need to search for bone driven controller and set the source bone to wheel 08. This wheel, the left wheel, and source component is translation Z, and the target bone is wheel 08 track, this LF, and the translation Z next to this. And copy for all the wheel that we use. The left is 7, 1, 2, 3, 4, 5, 6, and 7. And set this to wheel 7 and track 7. Wheel 6, the track is 6. Wheel 5, the track is 5. LF5. And wheel 4, the track is 4. Wheel 3, track is 3. Wheel 2, the track is 2. And connect to this. Copy and paste this for the right wheel. Next. And you can adjust the suspension to see this effect. Go to BP 10 wheel and this suspension and and you can add object, this cube, and this y is 10. Adjust this spring preload to lower, and let's play test. And now you can see the track is follow this wheel. And adjust it back to 5000. Set the spring rate to 5000 and this suspension 5 and 5. And this physics, this mass, you can set this to 0. This one is 0. And this one is mass depend on the body. And for this turn, we want the smoother turn. We shouldn't use this slurp. Set it to 0 when it's true. And let's play test. Now it have the smoother turn. Now let's figure out how to rotate the thread of the tank. Go to BP tank and ABP tank. Open the vehicles. This ABP tank M1 and go to event. Update thread. Copy this event. Paste it to the event graph. Promote this to variable. And we update this thread. Go to anim graph and we call transform bone modify. Select the bone is turret in, and the rotation replace existing. Get the turret rotation and connect it to this rotation. And another one is copy this, set it to gun in, and get gun rotation. File, open BP Waste Tank M1 and find the rotation. This turret rotation. You can copy both of these, turret rotation and gun elevation. Go to VP tank, paste this, and name instance or set turret angle. And gun elevation, set gun elevation. Delete this. Add a new function. Name is get turret angle and get camera, get forward vector. Delete this and make vector. We get the vector x and y. Then we normalize it to become unit vector. And get vector forward, get forward vector, then call vector forward dot product it with this camera vector and call equals degree vector right and dot product with this forward vector of the camera, and if it's greater than 0 we select float. And for equals, connect it to A, and if it is less than 0 get the 360 degree and minus with this degree. And we get actor rotation. Like this and subtract it with the yaw rotation of the actor. Call make rotator and copy this and paste this result to yaw. Add new variable. Name is angle. Variable type is float. Get this angle. And we want to loop from the original angle to the new rotation of the camera. So call or interp 2 from the current, and this is the target, get per data second, and interrupt speed we add to this get correct angle, name is interrupt speed, variable type is float, file get interrupt speed, next to this interrupt speed, and break vector, break rotator, and when we return we add return, the return is name is yaw, and connect it to this yaw, and file the event set this to pure function, and after that we go to event tick and get turret angle, set the interrupt speed to 12, set it to angle, and then we call set turret rotation, file let's play test. Now when we turn, the turret turn to the rotation of the camera. For the gun, we have to go to MEP tank and go to this transform, modify bone, and set this rotation space to parent bone space. When we play, our gun is turning with the turret. Now let's fire the shell, or we shoot that command on this as movement, and create another event IA shoot, add variable, the variable name is shoot, and variable type is boolean, get shoot boolean, create a branch, go to viewport, add scene component, name is fire, and parent socket, set it to gun 1 in socket, and go to event graph, get this scene component fire, get ver transform, found actor from class, set it to the spawn transform. The class name is BP first person projectile, and if it's true we spawn this, and go to this waste tank, copy this gunfire, Control C, and paste it here, and we can set this scale to 0.6 and set this active, for the effect of the gunfire. New active. And after we shoot, we set this shoot to false. Create a timeline. And add track load time to shoot. Set this length to 2 seconds. To event graph and play this from start. When it finished, we set shoot to true. We don't want the tank to shoot multiple shells, so we have the timeline to stop it. So first we set this shoot to true. We can't see gunfire effect because we need to set this template. Go to vehicle and FX. Use this PS muzzle fire. The A2 template and select this gun socket parent. And this gunfire we not set active. We activate it. And delete this and reset. When it's true, we activate. And let's play test. And now when we shoot, we get the effect. And we have to wait 2 seconds before we can fire another cell. If you have any problem with the projectile not hitting the ground, you have to go to first person blueprint and BP first person projectile. This is how I set up this projectile. And go to collision. And I set this collision to block both static and destructible, that is the building. Now we need to control the gun elevation because we want our tank able to shoot up or down. Let's add new function. The function name is gun elevation. And get camera, get world location, get forward vector, and the world location, add it, and this forward vector multiply it by the float, to float, and 1000. We promote this to variable. Variable name is gun location. And then we call line trace for object. And it to start this one to the add location and make the array. Array is both static and destructible. And we can debug it for 1 frame. For the out hit, we break the We break the result, get mesh, get socket, bone name, get socket, location. The name is gan in. Find, look at rotation, and if it hit, we select. If it fall, we select this scan location. If it true, we select this location. And connect it to the target. Click this rotation. Call F interp tool. Get add new variable. The variable name is scan angle. Variable type is float. Get scan angle to this pitch. And we get var delta second. To delta time, interp speed is 2. And then we set to scan angle. Make it to this line trace. And call set scan elevation. Go to event graph. On event tick, we call this scan elevation. And let's compile and play. Now you can see this line trace from the camera forward, and when it's hit, our gun will elevate to that level. You can see here, and it shoot the ammo to that location. And we can disable this debug, and we want to create the gun side widget to trace where we hit. So go to the tank folder, add new widget, user interface, widget blueprint, user widget, name WB gun side. Open this, and we need to import the texture. You can download it, link in the description below. And this is the texture as import. And we open gun side widget, search for canvas, and add this canvas panel, and add gun side center to this canvas. Set the anchor to center this position x to 0, y to 0, align 0.5 and 0.5. The scale is 150 and 150. Image size, it is 32 and 32. And now we add another gun size, this image. Set the anchor to this left, and scale size is 125. 125. Align is 0.5 and 0.5. And now we have this canvas panel. Now we have this widget. So let's go to BP tank. Go to event graph. For this sequence, we need to move this down and create widget. Choose the widget that we just created. This WP can size next to this, and the return value we add to viewport and promote this to variable. This variable name is can size. And let's play. You can see this can size at the center of the vehicle. And to trace the gun size, we need to go to BP gun size and graph, add variable. The variable name is screen position. Set the variable type to 2D, vector 2D. And we get this image 170 for the event tick. Get slot as canvas slot and set position. And set it to this screen position. To in position and save. Add function. The function name is can size screen. And we create a line trace for objects. Make array for object type, var static and var indestructible. Get mesh and get cockpit location of gun in, and get mesh, get cockpit rotation of gun in, and get rotation x vector, multiply it with the float is 7,000, and add it with this location. And this is the start line trace. This is the end of line trace. After that, we break the hit result and call select. Use this Boolean. If the trace is false, we get this at position. And if it's true, we get this location. And we get player controller project world to screen. And this is the world position. We project it and we get gun size widget set screen position to this. And one graph go to event tick. We call gun size screen function. Sorry that I called the wrong socket name. To avoid this wrong socket name, let's go to this skeleton and search for gun. We call this gun JNT, not INT. Copy selected bold name and paste it to this gun elevation function with the socket name. And this one, we paste this gun socket name. And we need to claim the pitch value of this gun elevation. So our gun not point too much upward or too much downward. For claim float. And the min is -3 degree. Max is 20. Set it to the target. And this gun size, we project world location to widget position. Use this world location to screen position. And let's play test. Now we get our gun size. And the gun size show where the turret pointed to. And now go to vehicle and open this blueprint. And we find the missile. This line, set line missile. Copy this. Go to BP tank. One graph. Paste it here. Because it is daytime, so we want to set line missile to 0. Now I want to create the smoke for the wheel. So open this and copy all this wheel VFX. Select by press Ctrl C. Add a new scene component. Name is smoke. Paste it inside this. Move to smoke. Copy this set wheel VFX. Paste it here. And this wheel smoke intensity, we set it to this intensity absolute. Because we will turn left or turn right. This one is 0.1. And go to the smoke. Because this smoke is too dark. So go to color overlay and set this V to 0.4. Okay. Go to the tank and I want to activate this smoke when the tank turns. So set the trigger. This set wheel smoke intensity and its intensity this action value. When we complete, we set it to 0. Compile. Let's play test. Now when we turn, we get this smoke on the tank wheel. But now our vehicle, if we flip this tank, let's rotate it 180 degrees, move up. When we play, we still can rotate this tank, so it's unrealistic. To solve this, we need to go to BP tank and add function. The function name is vehicle flip. Get mesh, get up vector, call vector up, and dot product with this vector up. If it's greater than 0, and we return the value and name this is return value. Connect it to the return value and go to event graph. Set this to pure and we get this vehicle flip. Create the branch. If it's true, we turn, and if it false, we not turn. Let's play test. Now we can turn the vehicle when the tank is flipped. Let's rotate it and move it down. And this is our result of our tank. Now we can rotate the turret and shoot. Thank you very much for my Patreon member who are supporting me. You can download this project in my Patreon page. And if you like this tutorial, please hit like and please subscribe to my YouTube channel. See you in the future tutorial.